well, the topic of all of us is images and signals, but mine more specifically is about video classification using neural networks and other deep learning techniques, and then applying some sort of activation maps to give attention to the network and also to know what's going on, for us, to demonstrate that it's actually a helpful tool for everyone.
Okay. Well, my bachelor thesis is focused on image analysis of the brain based on MRI, and the possibility to be able to identify regions of the brain that are related to schizophrenia and bipolar disorder.
Well, my bachelor thesis, more than image analysis, it's more focused on image reconstruction or as I say, estimation, because basically we have a type of MRI images of the heart, which are T1 images, which basically take normal magnetic resonance images and basically estimate the value of T1, which is a magnetic parameter of tissues, and they display it pixel-wise in the image. Now, the reconstruction or the traditional estimation of these images is very costly computationally, and it also has some problems with noise, etc. So what we're working on is to basically develop a deep learning algorithm that is able to do this reconstruction in a faster and more robust way.
And in my case, I would say that my thesis is a bit different than the others. It's not so focused on image processing, but more on signals. And also, I'd say that the application is quite different. So my thesis is based on trying to process intramuscular electromyography in order to obtain from the EMG, from the raw data, a set of strings of bits, of zeros and ones. And so in using different algorithms, try to see if we can obtain strings that are really random. And such strings that are random would be used in order to encrypt the communications between devices that are being developed, so for future applications.
Yeah, the first one, I hope, is helpful. It's the most important thing. I would like to say also maybe innovative, if everything goes well. And the last one, I don't know, hard work or whatever. So this.
Okay. Yes, for me to start, I would say innovative, to be able to develop new techniques and apply them to clinical cases. And then bright, at the end is to be able to generate alternative methodologies and expanding as the field is still growing.
Well, in my case, I would go for robustness, realism, and efficiency, because our aim in the end is to be able to generate these maps with worse quality images. Now, also we would ideally want to take into account some non-idealities when it comes to acquiring MRIs. And finally, all of this, what it will do is it will shorten the time it takes to acquire these images, and it will ultimately increase the efficiency in clinical workflows when acquiring these images, which is also something that attracted me a lot when I wanted to choose this topic, the practical application.
And for me, I think the first one would be security, because we know that medicine is going to is developing in a way that we are doing a lot of communications and sharing a lot of medical data. So it's important to develop ways to secure such communications. Then, as two others said, innovation also, because it's a new way that it's still being developed by some other studies, state of the art, but it's still not applied, I would say. And then also a real, as Paul said, realism, because it's something that really can be applied, realism. So the idea is that hopefully I develop something that could be really
Yeah, well, I mainly chose this because it was a way to do deep learning that we hadn't really seen in the degree. We worked with images and a little bit with signals, but there was anything on videos, and I think it's just a really nice move from the normality. And I thought that was a great way to do research. I chose it.
Yes, so the attracting phase of my field would be the practical appliance of this. Well, to try to diagnose real diseases from images of the brain.
In my case, the main reason for the choice of my bachelor thesis topic wasn't so much the topic, but the fact that it allowed me, it offered me the possibility of collaborating with a researcher who is currently working at GE Healthcare in a company, and also with hospital clinic, which is something that I feel that will give me relevant experience for the future when I want to go into the job market, and also it's something quite different from what we have experienced during the degree.
And for me, the idea was to get to know a different field that I didn't really know and that I hadn't seen during the degree. So it was to see a new field, and also the possibility to develop a thesis that could be really applied in the future in something being developed right now.
What I want to learn is just a continuation of what I've been learning, new ways to solve some of the problems using this massive field that is deep learning with different branches, some of them that are really, really popular, some of them that are not that popular. That is the thing that I want to learn more about this. And if I'm going to continue with it, well, I like it. I'd like to continue looking for this on some things, but there are also other branches and not deep learning related that interest me. So maybe we'll see.
So in my case, I would I'm trying to learn how wide is the field of image analysis, to try to try different artificial intelligence techniques and machine learning, and also how radiomics could be applied to detect or can be used for the diagnosis.
Well, in my case, I would say that the most important thing that I can learn about through my bachelor's thesis, I think it's about the real application of deep learning pipelines in the clinical world. Like, my project is not about something that is so state of the art like ISACs. Like, I'm actually using quite simple convolutional neural networks and things of this matter. But at the same time, what I have to develop has to be applicable in the clinical world. It has to go from my bachelor's thesis directly into the cardiology imaging service at hospital clinic. And this is something very different from what we have done during the degree, where we tackle a specific challenge in medical imaging, and we basically develop a little script and make it work, but then this stays there. And this is also, as I said before, one of the most appealing, and also one area where I think I will learn the most.
And finally for me, what I expect to learn is just learning which are some of the problems to solve that they are in the topic where I'm working, and just to learn all the applications that a signal can have, because I never thought that biophysical signals could be used in cryptographic applications. And yeah, I actually would like to keep working on signal and image processing. Maybe, as I said, not in the topic such the one that I'm working right now in cryptographic, but I do love the field of signal and image processing, and so I believe that it is something that I would really enjoy keeping working on.